Okay, so we're discussing systems of equations in two variables, and we're going to start right now. Yes, Maria? Okay. Okay. Thank you, Maria. Oh, yeah, sure. Yeah.
So I'm going to go ahead and have a graph here. Just go ahead and initialize your name.
So you have to do it the whole week, huh?
No, it's just, well, yeah, pretty much.
Okay. All right, so we're going to start. Okay. Are you guys ready?
Yeah.
So, as I said, chapter 8 is system of equations in two variables and three variables. We start with graphing. Graphing a 2x2 system, so we will graph two lines and see what happens with the two lines. How come we have a solution which is unique, or how come it has infinitely many solutions? How come the system has no solution at all? Yeah. Okay, so let's start. Actually, you guys are ready. Give me a second. Yes. All right, so solve each system graphically. Okay. All right. So 8.1 systems of equations in two variables. Okay. Yeah. What is the system of equation in two variables? It looks something like this, for example. Y minus x is equal to 1. So it has two variables, and there is another one. Y plus x is equal to 3. Yeah. So if I graph the first one, it will be a line. The second one will be a line also. Right? And we want to find the intersection because the intersection will be the solution. Okay. So let's do it. So for example, solve by graphing. So what we will do is we will write case 1, and then we will keep 5 lines blank. So actually 4. 1, 2, 3, 4, and then we are going to start here. Y minus x is equal to 1. Y plus x is equal to 3. All right. So I'm going to review graphing with you a little bit. Now, this is my first equation, and this is my second equation. This is the way we label equations. So we put dot, 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 and then 1. Dot, 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 and then parentheses 2. Why don't I label my equation like this? Why don't I do it? Yes, look at these. It looks like you're multiplying. So we never label our equations just like this. We need a few dots, usually 3 dots. Okay, so we never label the equations the other way around. So now, let's graph the first one. So in general, we only graph in this section. Usually we don't graph because we have other methods, substitution, elimination, but we will graph it first so you know, oh, why does it have a unique solution, etc. Now, how do I graph this? Y minus x is equal to 1. Any idea? Solve for y by itself. So y is equal to x plus 1. Good. And let's see here. Do I know the slope? What is the slope? 1. The coefficient of x. The coefficient of x is 1. What is the y-intercept? 0, 1. Yes. Good. So we could graph the line. Yeah. Now you should use graph paper because it's a lot easier. Like me, it's a little difficult. Yeah. But as I said, it's easier if you use graph paper. So if not, we have to try our best so that the tick marks are equally spaced. So what I mean is, you can't do it like this. So look at these. What's wrong with the tick marks? They have to be equally spaced. Okay? So you can't really graph something like this. That's why graph paper is the best, if you have. Right? Now, how do I graph these? I start with my y-intercept, which is 0, 1. Then what do I do? The slope is 1. What does slope 1 mean? What do I do? Rise over run. So we go up 1, go to the right 1. Is everybody familiar with the slope? Slope is rise over run. So this is 1 over 1. You go up 1, rise is 1, and then rise 1. Run is 1. What is this point? We have to label this. 1, 2, that's right. And then we will draw a line through these 2 points. Okay? Now, this is a line, so it shouldn't stop at 1, 2 or at 0, 1. It should extend all the way. And what's the end of the line? What's at the end of the line? You have an arrow, meaning it goes on forever. Yeah, that's why we put in this arrow. In MathExcel, unfortunately, we don't have arrows, so it's just going to be like a line. Yeah, and we will label this line. This line is y minus x is equal to 1. All right, so we're done with the first line. Now the second line. Here. Y plus x is equal to 3. How am I going to graph y plus x equals to 3? Yes. So solve for y. So I need to move the x. What happens to x? Negative x. Yes. Negative x plus 3. Or you can say, oh, I'm subtracting x from both sides. So what is the slope? Negative 1. What is the y-intercept? 0, 3? Okay. Good. So, how do I graph the line? I start where? With my slope or with my intercept? Intercept 0, 3. So this is here. And I'm labeling it. So the points that I use, I will label. Yeah. Now, slope is negative 1, so this is actually negative 1 over 1, right? So rise is negative 1, run is 1. Rise, what does rise mean? Up and down? So down 1. Why do we go down 1, not go up 1? Negative 1. Yeah. Yeah, you can. But if we're taking it as negative 1 over 1, then we will go down. Yeah. But yeah, you could do 1 over negative 1. So go down 1 and run is 1. So go down 1, go to the right 1. Oh, we're using the same point. All right. So do the same thing, draw the line, and label this. Y plus x is equal to 3. Okay, now I'm done. I just need to write down the solution. What's the solution? Solution to the system. 1, 2. Why is 1, 2 a solution? Yes, this is where they intersect, which means 1, 2 fulfills the first line and also the second line. Only 1, 2 does it. Yeah, because this is where they intersect, so it means it fulfills the first line It follows the first equation, and it also satisfies the second equation. It satisfies both equations. Yeah. So I'm going to write here why this is a solution, because 1, 2 satisfy both equations. All right. Is it easy? So this is review of graphing. So case 1, let's write case 1. The lines intersect. So now remember, I asked you to write down the, skip a few lines. So intersect like this. Intersect. Yeah. How many solutions? 1 solution. Okay. Oh, did everybody sign the roster? Oh, you didn't sign? Okay, thank you. See you tomorrow. Okay. So anyway, Maria said that Kirby Dominguez, he has sent your names to the bookstore, so you could buy them at Excel. Yeah? Okay. Anyway, we are continuing now. Where were we? Oh, it has 1 solution, and we call the system independent system. Why? Because you have 2 equations and two lines. So 2 equations represent 2 lines, 2 different lines, distinct lines. Okay? That's why we call the system independent. So later on, there will be dependent systems. Now, also, we say that the system is consistent. Why do we call it consistent? Because it has at least 1 solution. Oh, I am sorry. It has at least, and then I continue here. 1 solution. Okay. So goes here. It has at least 1 solution. That's why it is consistent. Yeah. Oh, we shouldn't say independent system, independent equation. So I just made a change here. I call the equations independent. Not independent system, but independent equation. So each equation is independent of each other. Okay? Good. Question so far? Do you remember graphing now a little bit? Yeah. So what I'll do is I'm going to do case 2 and then case 3, and then we will do more afterwards. So right now I'm just going to do 1 example for each. Yeah? So ready for case 2? Okay. Now case 2. So case 2, and we will skip how many lines? 4 lines? Yeah. So solve y plus 3x is equal to 5. And then the second one, y equals to negative 3x minus 2. So remember, we have to label. It is a good idea to always label, because we have more than 1. Y plus 3x is equal to 5. All right. Should I give you time to try to graph the first and the second? Okay. So let me give you time to try, okay? So what would you do first? Solve for y. Okay, so y is equal to,
The first one?
yeah.
Y.
Good. Y equals to negative 3x plus 5. Does everybody get that?
Yeah.
Okay. So what's the slope? Yes. And what is the y-intercept? 0,5. Yeah. So you know what to do, right? So you start at 0,5 and then what? Go down. Go down 3. Go to the right 1. Okay. Okay, I'll let you finish. And then we will discuss it. Okay? But you should try first. And then I want you to tell me what the solution is. I'm going to call the attendants right now. Okay. Chris Barajas. Okay. Estefania. Dolores. Oh. Jocelyn. Poheng. Poheng is sitting there. Jaylene. Jose. Brenda. Brenda Coyote. Not here. Matthew. Anthony. Faria. Oh. Carmen. Ronnie. Christian. Brianna. Francisco. Okay. Denise. Jeremy. Robert. Okay. Okay. I'm trying to remember everybody's name. So later on, when you answer questions, or if I ask you questions, I'm going to ask your name. Okay. So nothing personal. I'm just trying to remember everybody's name. Enrique. Kevin. Miguel.
Here.
Catherine. Oh, I think she dropped. Vanessa. Alejandra. Maria. Natalia. Alejandra. Hugo. Okay. Celeste. Jasmine Ibarra. I can read this. Anthony Bursano? What's your last name? Bursani? Okay. Victor? Victor Aguayo. Did I call everybody? Yes, I did. What's your name? Did I send your estimates yesterday? No? Okay. Oh, okay. So you're new today?
No, I came yesterday, but remember at the end of the class?
You have to leave early or something?
No, I was here, but I moved out back to that class.
Oh, okay, okay.
My
Okay.
name wasn't on the roster.
Okay.
But I did get a syllabus.
Okay.
Yeah.
Okay, so I'll do it later. Okay. Thank you. All right, so let's start. Are you done? What's the solution? So what's the solution? No solution. Yeah, how can they meet? There's no intersection. Yes, but let's do it. So what did you do here? Negative 3x plus 5. Yes, so the slope is negative 3 and 0,5. Good. And we could start graphing that. So I think everybody remembers how to graph. Am I right? Okay. Maybe I have to make this a little longer because it's 5, right? Okay. Let me just erase everything. Not better? X, Y. So 1, 2, 3, 4, 5, approximately. So we'll try our best to make the tick marks equally spaced. Okay, so how am I going to draw the first one? 0,5. You use this, then we will label. Then what am I doing? So slope is 3, so rise is negative 3, down 3, so 1, 2, 3, then right one. Label this. Yes, 1, 2, and draw the line. And label. It has to be straight, or at least I can pretend that it is straight. Okay, so y plus 3x is equal to 5. Okay. Now the second one, I could use a different color so it's easier for you to see. Y is equal to negative 3x minus 2. Oh, this is already in slope intercept 4. So we know the slope. Negative 3. What is the y-intercept? Okay. So now 0, negative 2 is here. What am I doing now? Yes, so rise is negative 3, go down 3, and then go to the right one. Okay, so this is not long enough, right? Yeah. So, okay, anyway. You can use your imagination, it is straight. Oh, it's definitely not straight, but what can we do? Okay, so use your imagination, this is straight. Okay, so what is this point? We have to label this. 1, negative 5. All right, so draw the lines. Actually, the second line doesn't look too bad. Ugh. All right, and label this. Y is equal to negative 3x minus 2. So tell me what the solution is. No solution. Why not? Yeah, they don't have any intersection. There's no intersection. So case 2. So I'm going to write the lines are parallel. So, and I'm going to draw something like this. They're parallel. Okay. How many solutions? No solution. What type of equation? Dependent or independent? How many lines do I have? 2. So how many equations do I have? So they are independent, right? Because it's called independent equation. Look at them. They are 2 different lines. So two lines represent, two equations, sorry. Two equations represent two lines. That's what I was going to write. Represent two distinct. Distinct is different. Now, how about the system? Consistent or inconsistent? Inconsistent. Why is it inconsistent? Well, because you don't have any solution, right? That's done. So the equations are independent, and the system is inconsistent. It's called inconsistent because the system has no solution. The equations are called independent. Why are the equations called independent? Yeah, you have two equations and those two lines are different. Yeah, they're distinct. All right. Okay. Continue. So we're doing case 3 now. All right. Finish?
Yeah.
Okay. By the way, usually in class I will ask you to do something like today. I will give you time to do it. Just do it. Yeah. And you're using pencil, right? Just say you make a mistake, so what? Just erase it. The most important thing in math is to try. You cannot learn math without doing math. Like, okay, they're playing baseball now, right? Can they learn baseball without actually touching the bat and the ball? Cannot. So same thing as math. You need pencil and eraser. So you just have to do it. Yeah. So don't be afraid. Oh, let me just wait because I don't want to erase. No, you just erase it if you make a mistake, and probably you won't make a mistake. Is that right? So that's your mentality. Yeah. You need to do it. You just got to do it. Yeah. All right. Now next, case 3. Same thing for lines blank. Okay. So solve. Let me see what I wrote for case 3. 3y minus 2x is equal to 6. And 8x is equal to 12y minus 2. Oh, let me see. Let me close the door. Okay, so can you guys try it really quick? Actually, that's not 2, right? This is 24. Yeah, this is minus 24. So this one right here, this is not minus 2, this is minus 24. I just cannot see it on my notes. So this is minus 24, okay?
So what would you do on the first one?
Yeah, same thing. So for y, yeah. Okay, so the first one, let's see. Are you guys done? No? Yeah. Maybe 2 more minutes. What's the solution?
For the first question?
For the system.
Oh.
Yeah. Okay, so let's do it. 3y minus 2x is equal to 6. Alright. Then how do we solve for y? Yes, so 3y, what do I do with the negative 2x? Yeah, so 2x plus 6. Then what? Divide by 3 both sides. So y is equal to, okay, so what's the slope? 2/3, and y-intercept? Okay, so let's draw. What is the solution? What did you guys get? They're the same line. So what are the solutions? No solution? Infinite? What? Or what? Okay, so let's graph first. 0,2 is here. Label this. And what do I do? So rise over run. Rise 2, run 3. Rise 2, run 3. So 1, 2, 3. Here. What is this point here? Label this. 3, 4. Yes. And then we will draw the lines. Extend this also here. This is the line 3y minus 2x is equal to 6. Okay, good. How about the other one? 8x is equal to 12y minus 24. So what would you do here with the y? Yes, y by itself. So 8x plus 24 is equal to 12y. Then divide by 12. Let me write it like this. 12 is equal to 8x plus 24. 12y. Yeah. And then what? Divide by 12? Yes. Because if you say 8x plus 24 equals 12y, it's the same as saying 12y equals to 8x plus 24. That's what we'll get used to, right? The y is on the left. That's why we moved it on the left. Can we leave it on the right? Of course. Yeah, it's just that we're used to writing it as y equals mx plus b instead of mx plus b equals to y. Yeah. But can you leave the y on the right? Yeah, of course. So y is equal to, what is 8 over 12? 2/3. What is 24 plus 2? 2. So what is the slope? 2/3. The y-intercept. Okay, and they the same? Yeah. So this is the red graph also. So the red one represents 8x is equal to 12y minus 24. Right. Now, how many solutions does it have? Where are the solutions? The line, right? Isn't it? No, is it only this? Okay, is it only this two? Everything, right? So we have infinitely many solutions, and if I ask you what are the solutions, it's all points in this line. So if I say it in words, then solution is all points on 3y minus 2x is equal to 6. Or I could write down this equation, 8x equals 12y minus 24. Right? But I have to write it in symbols. So solution is all the ordered pair. So x comma y such that 3y minus 2x is equal to 6. So this is how we write it. Yeah. So solution is all the points, all the ordered pairs on this line, 3y minus 2x equals to 6. And some of you might ask me, well, what about the other line? Can I just use the other line? Yeah, of course. Why? Because it's exactly the same line. So when you label the line, you can either label it with 3y minus 2x equals 6 or 8x equals 12y minus 24. Does that make sense? Okay. And does anyone have any questions with this? This is just all ordered pair x, y, and then this represents such that. So that vertical bar is read as such that. Yeah, you've seen it before, right?
Yeah.
Okay.
Those are brackets, right?
This is a curly bracket, which is for set. So brackets are like this, right? But what I used for set here, this is a set builder notation, is this bracket. Yeah, it's a curly bracket. Yeah, they call it curly bracket. Yeah. I'm not making it up. Okay. Okay. You have questions? You can ask. Yeah? Sure. You can ask anytime. Yeah. Okay, good. Now, case 3. What happens to the two lines? The lines overlap, right? Or in math, we usually call it coincide. So the two lines coincide. Overlap means the same thing as coincide. So co means together. Yeah. And tell me the solutions. How many solutions? Infinitely many solutions. Infinitely many solutions. Okay. Yes? Oh, which one? Oh, did I? No, look at this. Actually, when I bring it to the other side, you're adding 24, right? So, or you can think of this. If I move a number or an expression to the other side of equal sign, so if it passes through equal sign, then the sign changes. So I move it to the other side. So this is correct or not? Yes. So then what I did was, instead of saying A equals B, I could say B equals A, can I? So what I did was just that. So I'm writing the 12y is equal to 8x plus 24, which is exactly the same. Does that make sense? Okay, so yeah, it is positive. Yeah, okay, thank you, good question. This one. Oh, yes, thank you, Miguel. So this is 12? Yeah, thank you. So you're Miguel, you're Jaylene? Okay, good. Jeremy, Denise, Christopher, Jasmine, and Stefania. I'm trying to remember. Yeah. Good. Let's see. It's infinitely many solutions. What about the equations? Are they dependent or independent? Dependent, yes. Why are they called dependent? You only have one line, right? Good. Dependent equations. Yes, you have two equations but only one line. Two equations represent only one line. So that's why they're called dependent. Good. How about the system? Consistent or inconsistent? So you're being asked, does it have solution or not? Yes? Does it have solution? Yes. So is it consistent or inconsistent? Consistent, yes. Yeah, it has more than one. It only needs one. Consistent system. Has at least one solution. In fact, it has infinitely many solutions. It has at least one. Yeah. What are the solutions? Can you just say infinity? No. Why? Because if I choose this point right here, okay? If I choose this point here, is this point a solution? No. So what is the proper way to say what the solution is? All points on the line. Yeah, and if you want to write it using symbol, it is all points is using ordered pair x comma y, such that, and then we write down the equation of the line. You can use this equation or the second line. It doesn't matter because they're the same line anyway. Yeah. Now, is it easy? Okay, so you're going to try to do a few more on your own. Okay. So I'm going to give you more. And then you have to tell me how many solutions, whether the equations are dependent or independent, consistent or inconsistent. Yeah? Okay, good. So now, let's do. So solve by graphing. And then also state the number of solutions. Whether equations are dependent or independent, and also one more, system, whether system is consistent or inconsistent. Oh, it gets warm here, isn't it? Okay, let me adjust the temperature real quick. But let me write the problem first, okay? So, number one. Okay, we have y is equal to negative 1/4 x plus 1. 2y is equal to x minus 4. Okay, let me just do it. Oh, it's 80 here. And then if you're done, do this number 2. X minus 2y. Minus is equal to multiply 3y. So Raul, so you know what to do with this, right? Addition. Yeah. Mm-hmm. What's the answer for number 1? Solution? Yeah, what is the solution?
Oh.
What is it? Okay, yeah, sometimes you see, if you have to read it, you have to graph it really carefully, right? Yeah. So it's supposed to be 4,0. Yeah, but I mean, it's really hard because once your line is a little bit off, then you can't really read it correctly. That's why your what is it called? Your tick marks have to be equal. But if you use graph paper, it is a lot easier to read it. Yeah. Now on the exam, I usually provide you with the grid line, so you don't have to worry about it. Yeah, it's like graph paper. Okay, so 4,0. How about number 2? Maybe not. We're working on. Okay, so let me give you 5 more minutes, then we will discuss them. Yeah. Should we discuss it now? Okay, number 1. Let's see. Y is equal to negative 1 over 4x plus 1. So what's the slope? What is it? Oh, we're doing number 1. Negative 1 of 4? Yes. The slope? Yes. Okay. All right. So hopefully the tick marks are equally spaced. It's a lot easier if you use graph paper, as I said. Alright, so this is x-axis, y-axis. Now, start with 0, 1. What do I do? Down 1, 4 to the right. So down 1, 4 to the right. That's here. And draw the line. Yes, Anthony? Mm-hmm. You could do either way, but not both. So if I write negative 1, so negative 1 over 4 can be written as negative 1 over 4 or 1 over negative 4, right? So if you choose this one, then what we do is we rise negative 1, which we go down, and then we go to the right 4. If you choose this one, what are you going to do? If you choose this one, go up 1 and then to the left 4. So it's actually the same line, it's just that you're using, so if you go up 1 and go left 4, it's going to be here. So it's going to be the same line, it's just that you're using different points, that's all. But it doesn't mean it can be negative 1 and negative 4. What is negative 1 over negative 4? That's 1 over 4. Yeah? Okay. Good questions, Anthony. Okay. Now, anyway, let's continue this one. That's a good question. Yes, so the negative, you can associate it with the numerator or the denominator, but not both. Yeah, because negative 1 over negative 4 is positive 1 over 4. Okay? So either way, either this or this is good. Yeah. Now, let's write this equation. Y is equal to negative 1 over 4x plus 1. Okay, how about the second one? Yes, so y is equal to half x minus 2. So what's the slope? 1 over 2. What's the y-intercept? 0, negative 2? Yeah, you're right. I was wrong. I didn't put the negative. You're right. It's 0, negative 2. So what am I supposed to do here? Start at 0, negative 2. Then go up 1. Go to the right 2. Yes. And this is, label this 2, negative 1. Yes. Alright, so yeah. Alright. So this is y is equal to half x minus 2. Oh, I could write these or I could write the original equation. It doesn't matter because they're the same. But I could label it with 2y is equal to x minus 4. Yes. So what's my solution? Yes. 4, 0. Now, tell me about the equation. Independent equation. And you know why they're called independent equations? Yes. So I'm not going to write the reason. We all know why. Right? You have 2 equations and 2 lines. How about the system? Consistent or inconsistent? And why is it consistent? It has at least one solution. Easy? Okay. Good. Next one. Yeah. Is this okay? Any questions you can ask? No questions?
How is it consistent?
What does it mean?
Yeah.
It has at least one solution. Yeah. And then Consistent system means it has at least one solution. Independent equations mean two, well, the equations are independent. Two equations are two lines. Yeah. Good. Yeah. So next, did you finish the other one? What's the solution for the other one? No solution? Okay. Yeah. Yeah, you're right. So let's do the other one. Okay. Let's look at the other one. Okay. So the first, label this first and second. So we have to do the labeling. It's a really good habit. Later on we will do 3 by 3. If we don't label it, everything will be mumbo jumbo, mixed up. Yeah, so it's better we start labeling with practice. Now this one, what should we do? So 6x minus 2y is equal to 2. Now what are we doing? Yes, isolate the y, negative 2y. So 6x will become negative 6x plus 2, and divide each term by negative 2. Okay. So y is 3x minus 1. Okay, slope 3. Y-intercept? Yes, that's right. Okay. Same thing. Equally spaced tick marks. All right. So 0, negative 1 is right here. Then what are we doing? Go up 3 and 1, right? So this is 3 over 1. It's just the 1 is invisible. Label this point here. 1, 2. Oh yeah. The lines is so curvy. Okay, so this is 6x minus 2y is equal to 2. Okay. Now do the other one. Negative 3y is negative 9x plus 1. And then what? Divide by negative 3. So y is equal to 3x minus 1/3. Okay. So what is the slope? 3, and then the y-intercept? Yeah. Now I want to point out something. What happens to these two slopes here? They're the same. So that's how you know the two lines are parallel. Yeah. So all right. But anyhow, let's graph this. 0, negative 1/3. Where is negative 1/3? Where is negative 1/3? Should I go up or down here? Wait, where? Down. Well, this is 1, so looks like somewhere here, right? 0, negative 1/3. Okay. Now the slope is 3. So what am I going to do? This is not exactly on the tick marks, but we could still do it. Up how many? 3. So I'm going to go up 1, 2, and 3. Do you see it? Even though it's not at its tick mark, you could still go up. Yeah. And what happens? How many right or left? Right 1? Okay. So it's right here. Now, can we label this point right here? The point that we will use. So it is 1, what? And then let's just count. So this is 1, 2. This is 2 2/3, isn't it? 2 2/3. Or you could say this is 8/3. Now we're going to draw the two lines. All right. Yeah. Okay. So what is your conclusion? How many solutions? No solution. So let's just write this. If the slopes are equal, the lines R. Right? Okay, no solution. What about the equation? Independent. Why do you call it independent? Two different lines. Yes. How about the system? Why? And consistent. Yes. There is no solution. Okay, is it doable? Do you remember how to graph now? Yeah? Okay, good. Now, we have a few minutes, don't we? Come on, Miguel. Is it 11:40, right? Okay, so 5 minutes. Actually, it's just translating, but let me see. Should I just do it tomorrow? Okay. Okay then. Yeah. Okay. So tomorrow. Yeah. So remember, today I'll let you guys go early. Okay. Sometimes if I go a little bit later, don't complain. Yeah, we're done with 8.1. Now, Miss Maria, your counselor says that you can buy MathXL now. Your names have been sent to the bookstore. Does everybody know where the bookstore is? B7. Yes. In front of the swim stadium, north of the swim stadium. Okay. Okay, guys. Well, I'm done with 8.1. I will not close it, but you know I'm done with 8.1, so you could start 8.1. Actually, if you know the material, you could do all chapter 8 on your own, no problem. Yeah. Yeah.
But we need the Excel. Right?
Yeah, you need the MathXL. What is it, Christopher? Yes, the homework is already there. Chapter 8, chapter 9, whatever chapters you want to do is there. I'm not going to close the due date until next Wednesday. Yeah, but you know we're done. You don't want to wait till next Wednesday when I close it. Yes. Okay, see you tomorrow. Yes, Miguel, sorry. Yeah. Are you STEM major? What is your major?
No, my major is computer engineering.
Oh yeah, then you're supposed to take Math 120. I suggest if you have taken calculus in high school, I suggest that you look at your old, do a little bit of studying and then retake the placement exam. But they only allow you to do it every once a year. You know, so otherwise you have to take geometry. And then you have to take pre-calculus and trigonometry.
So I can just go for calculus after this?
No.
Pre-calculus?
Pre-calculus, yes, but you have to do geometry. In order to take calculus 1, you have to take trigonometry and pre-cal. In order to take trig, you have to take geometry. So this is what happens, okay? So this is calculus 1. It has two prerequisites. Do you guys have quick questions?
Can you use edition 5 instead of edition 6?
Yes, I'm using edition 5. Okay. Yeah.
I don't know if I could petition class.
To add, you have to talk to Adelante office. This is for first-year student. I don't give any slips. I'm not supposed to.
Okay.
Yeah, but are you in FYC? Are you a first-year student or not? Then they probably will not let you.
Okay.
Okay, but you should talk to B2106.
B2106?
Yeah.
Okay, thank you.
The MathXL probably, so it's just a download.
No, it's not a download. You just need Adobe Flash. Yeah. The book is online, or you could you can rent it out for $20.
So we can just go on there. We can just sign up every time we need.
Yes, if you signed up and then you open the homework, you want to look at 8.1. So go to homework. I should have done the MathXL today instead of letting you guys early. Yeah, this is the class. This Math 261. You know, this is too small for me. I'm an old person.
You're looking for geometry?
Yeah, this is Math 261, right?
Yeah.
The
Calculus 2.
Okay, so this is calculus 1.
Calculus.
This is pre-cal. Oh, okay. So this calculus 1 has two prerequisites: pre-calculus and trigonometry. And the prerequisite for trigonometry is Math 120. Okay?
So
So here, calculus, which is Math 261. This is Math 260 and Math 241. And then Math 241, the prerequisite is Math 120.
We store work on today, that's right.
Yeah. Yeah.
so
That's very fancy,
so then
but yeah,
I
you
could
can use
just
it.
take that.
Yeah.
Then I could just take trigonometry after 125 because basically Math 120 is that's before Math 125.
No, it's not before Math 125. Math 120 and Math 125 is considered one level. So look at this. Look at my chart here.
Because in high school it was different. It was
Yeah, it's
geometry
different.
first.
We
and
use
algebra
different.
two, then
Yeah, it's
calculus.
different. Our geometry is a little different. Yeah. So you should study and then retake the test. But next year you can't do it. You can only do it once a calendar year. Yeah. So what you could do next semester is probably enroll in Math 260. Oh, do you have a counselor? Kirby. Kirby, right? Okay, Kirby doesn't do it. Yeah, Adelante. Ask him what it is better for you to do.
Yeah, because he showed me during the orientation. He showed me that we could like from after math.
Oh, sorry. Let me close this first so they don't hear our conversation. When it's